Okay, so I did send out the notes. Actually, let me say this first. I hope everyone had a nice, weekend. So we're in February now, a new month, second week of classes. All right, so I hope everyone is having a good day so far. I did send out the notes, through email, so you should have them. Okay, so you can follow along with the lecture that I'm going to do. Also, I think I said this in the email. I hope I did. But if not, I'm saying it now. There will be homework on Wednesday, and it will be due Tuesday of next week. So, it'll be on Lumen Learning, okay? Also, I'm hoping to give the first quiz on Friday, probably. So it'll be like, I guess, in a sense, like maybe a few questions more like homework, because again, the quizzes are not going to be timed. They will be due, I'm guessing probably Sunday. If not, then Tuesday the latest, just like when homework is due. I'll keep everyone in the loop. I did work on the calendar, and the homework should be there. Excuse me, not there. The homework being assigned and the deadline, all that stuff, that should be on there. I think before I set it to personal instead of for the class, which is why I wasn't showing. So anyway, again, to get to the homework, it's on Lumen Learning. If you still cannot access it, if you still cannot gain access to Lumen Learning, please let me know, okay? The information is on the syllabus, okay? All right, so now that said, let me start the lecture. So I'm going to stop this. Okay. All right, let me share my notes. Okay, here we go. Okay. All right. Everyone see it? Yep, everyone can see it. Good, good. You can hear me. All right. So basically, I thought it'd be good. That worksheet I basically tried to give last time, but we didn't have too much time for it. So I think it might be good if I just, go through the solutions to it again, just to give you guys, so you guys have more practice. All right. So, excuse me. So again, the first question was, can you have a right triangle whose side lengths are these? Okay. And again, really what you want to know is, do these three numbers satisfy Pythagorean's theorem? That's really what you're trying to figure out. If it does satisfy it, then it is possible to have a right triangle like that. If it doesn't satisfy it, then you can't. And also remember, the longest side is always the hypotenuse. A squared plus b squared is c squared, c being the hypotenuse. That's always the longest side. Mostly because it's opposite the biggest angle in the triangle. Okay. All right. So now, okay, so can we have a right triangle like this? Well, again, this here, 50.5, would have to be the hypotenuse, okay? The other two sides here would have to be the legs. So let's say this was our right triangle. This is the hypotenuse. Here we have the legs, right? Okay. Okay. So we want to know, can this right triangle exist? Well, if it did, it would have to satisfy Pythagorean's theorem. Okay. That's what has to happen. Okay. All right. Well, let's see. 10 squared plus 49.5 squared, will that equal to 50.5 squared? That's really what we want to know here. Well, if you were to actually carry out these products, right, when you square something, you're multiplying it by itself. And if you do that, 10 squared would be 100, 49.5 squared is here, but the equation does actually hold. In other words, this equation, equations can be true or false. It is in fact true. So because of that, it is possible to have a right triangle like this. It is possible. Am I saying that there has to be a right triangle like this? Well, no, I want to say. But again, it's definitely possible. Now you might be thinking, wait a minute, why does this have to be the side of length 10? I know this is not drawn to scale, and this has to be the side of length 49.5. Well, it really doesn't have to be, but if you did interchange these two and got this right triangle, the calculation would still hold. Mostly because addition, remember, is commutative, meaning you can add two numbers in any order you want. So that's our first example. Again, it was on the worksheet. The worksheet, I know we didn't really have too much time to do it, but again, I just figured it'd be good to go through the questions that were on it. All right, so the next one is similar to this. Can we have a right triangle? So this is the next question. Can we have a right triangle with these side lengths? Can we have that? Well, again, you really want to know, do these three numbers satisfy Pythagorean's theorem? That's really what we're after. And again, the longest side has to be the hypotenuse. Okay? It has to be the hypotenuse. And 10 and 22 then are the legs, the length of the legs. Okay? So we're saying, okay, could this right triangle exist? Well, 10 squared plus 22 squared would have to equal to 48 squared, right? Pythagorean's theorem. Now, does that happen though? Well, we have 10 squared plus 22 squared. Would that have to equal to 48 squared? Well, if you do the calculation, it turns out the answer is no. On the left side, you get 584. And on the right side, you have 2,304. And this is not a true statement, so the answer is no. So it can't. Okay, and again, if you happen to interchange the lengths of the legs, so if you had this, if you had 10 over here and 22 over here, it would still be the same calculation. Well, almost, I should say, because 10 and 22 would be interchanged. But in the end, you'll get the same result, that you'll get an equation that's not true. You'll get this equation, actually, which is still not true. I thought I made the second right triangle on the next slide, but I didn't. Okay, so we have this example down. Now, what I want to do next is move on to this question. Here, let's assume we have a circle, okay, whose area is 12 square inches. We want to figure out what the radius and the diameter are. And once you get the radius, you're actually home free. The diameter is just twice the radius. So I'm going to say, let R be the radius of the circle. And that's what we're trying to find. That's our unknown, excuse me. Now we know the area is 12 square inches, right? And we remember we know the formula for the area of a circle. Namely, we have the area is pi times the radius squared. So we're going to get 12 square inches is pi times the radius squared, times r squared. R is what we want to figure out. Now, I like to have the unknown on the left side. I'm pretty sure most mathematicians do that. But again, if you left it like this, that'd be fine. But you want to figure out what R is. So what do? You solve for it. And that's what I'm doing here. Okay, so we can divide both sides by pi, right? Dividing, we get pi r squared over pi is 12 square inches over pi. Right? What happens here? The pi's are going to cancel. Actually, let me get the pen and show that. Although hopefully you can see that, right? These two cancel. I mean, pi does denote a real number. And we get r squared is 12 square inches over pi. I think before I've said inches squared. I think square inches is actually better to say. So we have r squared is 12 square inches over pi. We're not quite done yet though, right? We don't want r squared, we want r. But if you know r squared and you want to get r, what do? You take square roots. And that's what I'm doing here. So we have r is the square root, that's what this symbol is, of 12 square inches over pi. And that's the same thing as this. Inches square, square inches here, you could just bring that out because you have the square root. And so we have the square root of 12 over pi. Now, if you did this in your calculator, okay, right, what would happen is you would end up with this, something like this. And again, I know I didn't say how many decimal places to round to. I mean, here I'm going to round to 3, but again, I will tell you how many decimal places to round to. So we get this long number, and if you were to round to 3 decimal places, you're going to get R is about 1.954 inches. And again, that's just rounding off the 3 decimal places. Again, if you need help using your calculator, it's best to ask me in office hours, okay? I really want to try and finish chapter 1 by Wednesday, the latest. I mean, don't be afraid to ask questions, but, I just wanted to let you know. And again, once you know R, the radius, you get the diameter easily. You just multiply by 2. What I would do, though, is multiply this number by 2. Because then your answer will be more accurate. If you multiply this by 2, you're actually going to be off a bit. So again, you only want to round at the very end. So basically, you want to use this number for finding the diameter. Okay. Okay, let me pause the recording.